So this lesson is on the change of base formula and also on exponential equations. Now you know that your calculator can evaluate any logs with base 10 or base e, so this formula allows you to work out the logs of any base. You can see here the first example is log base 3. We're going to evaluate this log by using this change of base formula. But the first thing we're going to do is go through the proof of where this formula comes from. So if we were to say let y equal the left-hand side, which is the log of x base a, then we can change from log form to index form. A to the power of y equals x. And then we can take the log of base b of both sides. So log base b of a to the y equals log base b of x. Then we can use the third log law and bring the power here down to the front of this log. So that's y log a base b equals log of x base b. If we divide both sides by log of a base b, so on the right hand side we've got log of x base b, and we're dividing both sides of this equation by log of a base b, so we were dividing both sides by this term here. Now remember y equals log of x base a. So log of x base a is equal to log of x base b divided by log of a base b. And your log b, if you choose b to be either, say, base 10 or base e, then you can do this on the calculator, which allows you then to work out log of any number with any base. So that's the change of base formula there. So using that formula, let's evaluate log of 5 base 3. So that is going to be, we can either say choose base e or base 10, because that's what we can do on our calculator. And just making sure we have the same base for both the numerator and the denominator, and then you can see there the x there, which is the 5 there goes on the numerator, and a is the base in the original question, and that goes on the denominator. So just typing that into your calculator, and you should get, and if you did base 10 instead of base e, you should get the same answer. So that's 1.46497351. So maybe we can round that to 2 decimal places. That's 1.46. Simple as that. Okay. Let's have a look at some. So we've already done question 1 there. Let's have a look at question 2 and question 3. So solving a exponential equation where the pronumeral is on the numerator, on the power there. You learn how to solve exponential equations in the prelim course by trying to make the same base on both sides of the equation. Then when the bases are the same, you can say that the exponents or the indices are the same. But there's no way of making 11 into 3 to the power of a number. So another way is by taking the log of both sides. So if we were to take the log base e of both sides of the equation, we would get that. Using the third log law, we can bring the x down the front of the log, and then dividing both sides by log 3, we get that, log of 11 divided by log 3, and you can simply put that in your calculator, and to 1 decimal place, that's going to be 2.2. Okay, and similarly with number 3, solve 3 to the power of x equals 5. So 3 to the power of x equals 5. We're going to take the log of both sides, like that. Bring the power down the front using the third log law. Dividing both sides by log of 3. And I'm taking log base e on both sides of the equation in both the question 2 and 3. 2 and 3, you could also take log of base 10. You'd still get the same answer. I just like ln is one less letter to write down. so I think it's easier. And we have to do this to 3 significant figures, so 1.46 will be to 3 sig figs. Okay, let's have a look at some other exponential equations. So, same thing here. If we can't get the same base, if we can't change 3.6 into 2 to the power of something, then we're going to have to solve this exponential equation by taking the log of both sides. So, we'll take the log of 2 to the power of 5m plus 1 equals log of 3.6. So just by taking the log of both sides, bringing the power down the front of the log, and it's that whole power, so put it in brackets. And then just like we did before, we'll divide by log of 2. So we'll get log of 3.6 divided by log of 2. And then we'll have to subtract 1 from that value. You can either put that in your calculator now, but to avoid a rounding error, you could store that in your A memory, say. Remember, shift store A to store it in the memory. And then you want to subtract 1 from both sides of the equation, and then the last step is to divide both sides by 5. So I'm just writing the exact value of this down, and then we'll put it in the calculator all in one go at the end, whichever way you prefer. And then the value for m should be 0.17 to 2 decimal places. Okay, and then in example 2 here, we're going to do something very similar. We are going to take the log of both sides, but what is cool here is definitely you want to take the log base e of both sides, because then what's going to happen when you bring the power down the front of this log base e of e is simply 1. And you can test that on your calculator. So k is just going to equal log base e of 200. And to 1 decimal place, that is going to be 5.3 to 1 dp. So the important relationship there was log base e is equal to 1. Okay, and that's because you know how the little base here would be e, and e to the power of 1 equals e. So that's why log base e of e equals 1. And that was what we had here. Last example is a HSC question from the 2011 HSC question 1. And I'd like you to write down the question, solve 2 to the power of 2x plus 1 equals 32. And then I want you to pause this video and I want you to have a go at this. And then I will resume the working out for that, and then you can check to see how you went. So please pause the video now. Now you could have either solved this equation by taking the log of both sides, or recognising that 32 can be rewritten as 2 to the power of 5. So you can say 2 to the power of 2x plus 1 equals 2 to the power of 5. Whoa, that 5 was a bit messy. And now we've got an equation where the bases are the same, which means, and they're equal, and so that means the indices are equal. So 2x plus 1 equals 5, so 2x equals 4, subtracting 1 from both sides and then dividing both sides by 2. So hopefully you got that as an answer. I think that was probably worth about 2 marks in that HSC.